Hello, this is Miss Moore, and today during chemistry we're going to discuss isotopes. So today's essential question, how is average atomic mass calculated? Today you are going to need your calculator, so if you don't have it, go ahead and go grab it and come on back. Alright, so here we go. We'll start with talking about mass number, which is something we discussed yesterday. The mass number is the mass of an individual atom. Okay, so we're talking about how much one single atom weighs. And hopefully, as you know from yesterday, most of the mass of the atom is in the nucleus, which means that it's actually just the number of protons and the number of protons that determine the mass of the atom. Remember, both the mass of both a proton and a neutron are 1 AMU, so you can almost count to figure out the mass. And the equation we discussed was mass equals number of protons plus number of neutrons. So neutrons and protons each have masses of about 1 AMU. So you could count the number of protons and neutrons you would know the mass of an atom. All right, on to isotopes. The number of protons, also which is the atomic number, determines the element type. So all atoms of the same element type have the same number of protons. We discussed this in the last lecture. Every single carbon you meet is going to have 6 protons. Every single sodium you meet is going to have 11. Every neon you meet is going to have 10 protons. So it's actually the number of protons that determines the type of atom it is. Okay? So while atoms of the same element must have the same number of protons, and thus the same number of electrons, they can have a different number of neutrons. Remember, neutrons are neutral. And so while with protons and electrons you have to have the same amount so their charges can cancel out, that's not the case with neutrons. Okay, so atoms with the same number of protons but different numbers of neutrons are called isotopes. So isotopes have the same atomic number and the same number of protons, but differ in their masses because they have a different number of neutrons. Okay, so we can have a carbon. Again, carbon has 6 protons. Every carbon in the world has 6 protons. But some carbons might have 6 neutrons, some might have 5, some might have 7. So because it's the protons and the electrons that are responsible for the chemical behavior of an atom, isotopes are chemically alike. Okay, so even though one carbon has 7 neutrons and one has 5 neutrons, they still act the same. Let's talk about atomic mass. Because the mass of an individual atom is the number of protons plus the number of neutrons, the mass must be a whole number, right? You cannot have part of a proton or part of a neutron. Being that a neutron weighs 1 AMU, one neutron and its mass are the same, right? So if you have 1 neutron, 1 proton, you're going to have an atom with a mass of 2 AMU. You can't have 1 proton and a half a neutron. It's just not possible. However, as we noted the other day, the atomic masses on the periodic table are mostly in decimals, which would suggest that there's part of a neutron, but that isn't true. The atomic masses on the periodic table are what we call weighted averages of all the isotopes of each element. So we were talking a moment ago about carbon. We could have carbons that have 6 neutrons or 5 neutrons or 7 neutrons. So what the scientists did is they took all of the carbons they could find, dumped them on the scale, weighed them, counted how many carbons there were, and divided by that number. But they didn't know how many neutrons each of those carbons had. All they knew was that they each had 6 protons. So the masses on the periodic table, again, are what we call weighted averages. Most elements occur as a mixture of 2 or more isotopes. Again, an isotope is an atom that has the same number of protons but different neutrons than his other like atom. So the elements of isotopes are typically found in the same percentages, also known as fixed percent abundance. So for example, if we were to take a drop of water from anywhere, from the lake and the ocean, from your sink, from my sink, from the classroom sink, from wherever, In any drop of water, 99.9844% of the hydrogen atoms will have a mass of 1 AMU, which means all it's made up of is 1 proton and 1 electron. The remaining 0.156% of the hydrogen atoms will have a mass of 2 AMU. Those hydrogens have 1 proton, 1 neutron, thus giving you a mass of 2 AMU. And then, of course, 1 electron. It's these numbers that give hydrogen an average atomic mass of 1.01 AMU. So on the periodic table, the mass of hydrogen is 1.01 AMU. But again, that's an average. There is no single atom that has a mass of 1.01. It can't have part of a neutron or proton.